But for probabilistic models, we like that. We like that still because oftentimes our inputs are probabilities as well. Our outputs are maybe this, maybe that, right? So we use probabilities to describe to the extent of which how one outcome may be more likely than another. Example, if we invest in companies A, B, C, D, and E, which one will be more successful? Well, successful as in, for example, returning more than 10% returns after 2 years. So those are very specific parameters. But what are the chances that they are going to be successful? It's what we need, right? So in oftentimes in business decisions, we decide not based on amount of money that we can get, not based on the amount of success that we can foresee, but rather how likely, right, we are able to achieve that. Because if it's more likely to get $1,000 returns versus a very unlikely case of getting $100,000 returns, maybe it will swing us to decide or to favor the former, right? So in that sense, we also need models that tell us probability of getting success in company A, 30%, B, 20%, something like that. So at least after that, we can quantify the chances of success and then we can make a decision. Okay, so we can use the models to do all these uh, for various reasons, even when the outcomes are clear that, okay, we should invest in company A. Why? Well, because when we express the situation into model, whether it's deterministic or probabilistic, we allow more experts to come in. We said that. Okay. There's another very good advantage in doing so, even when it is quite clear that we should invest or act on certain outcome or choice, is that when things are being decided upfront, there is always an uncertainty, right? The outcomes are never guaranteed. Because if it's guaranteed that A will do well, guaranteed, then there is no choice to be made. You just simply execute. It's not a decision problem. A decision problem is it needs to crack our head exactly because the outcomes are not clear. We have to think through, right? So given that's the case, the outcomes may go south, even under the best advice. True, right? You agree with me? So when things go well, everyone is praising for your good thinking. But when things go south, even when you are very respected or credible, without a model to justify why you have arrived at that choice in the first place, you might be blamed, right? So the question is that if things don't turn out well, could anyone else have made a better decision upfront? Could anyone else have seen that coming in? According to our model, right, there is no parameter, no data, no equation, no model parts that tell us that such uh, poor outcome can result. And because this is a standard international language mathematics model, everyone in the world, given the same data and the same model, will, after number crunching, come to the same conclusion. Whether one graduates from Ivy League universities or other universities, doesn't matter. Whether you are from Europe, US, Asia, doesn't matter because this international language of the models, mathematics, is going to be the same for everyone. So same machinery, mathematical model, same data input. After the number crunching, it will be the same output. Suppose the model says invest in company A, and the outcome is company lost $1 million. They are pointing fingers at you. What do you say? And because you have done this lesson, you know that you should open source your problem in terms of models. You know that you should feed data in and arrive at an objective outcome. You know that the model says invest in it. and you followed through, right, with various considerations, you're going to vindicate yourself by saying that, look, upfront when we did all these, everyone was micro dissecting the model and churning through the numbers and interpreting the outcomes, and nobody voiced any objection to invest in company A. So please don't point your finger at me when such investment results in a loss for the company, right? Nobody could have foreseen that. Example, the COVID-19 pandemic invalidated all the assumptions. Example, right? So with the model backing us up, it gives us a sense of validation that objectively, with the totally cool numbers being fed in, the outcomes are well considered, they are measured, they are balanced, they are sort of modeled, right? With the best choice being company A. So as a matter of documentation, as a matter of arriving at the best conclusion, as a matter of justification, because the outcomes may be good, may be bad, right? All these are very important, salient points that encourage us to go on to mathematical modeling. So try to love mathematics, because we are going to use that a lot, but we're not going to inundate ourselves with mathematics here. In other words, we're going to borrow or copy and paste the outcomes from mathematics. We're going to use the theorems, the outcomes, the results, and fit that into our mathematical description of our business. We're not going to derive the results, the mathematical results. We're not going to reprove what has already been shown to be working, right? So instead, we're going to step on top of that complexities, use them to our advantage, and to help us make the best decisions in a given situation. Right. So once we can do that, we become more fluent, and we can have a choice even, right, of different tools to use in certain situations. Like maybe there are a few models that we can use, and then we become better at choosing a proper model to describe our situation.